Hi, Lisa here. Today we're going to discuss average and weighted averages. Finding the average, also called the mean, of a set of numbers. In order to do so, we first have to find the sum of the set of numbers. Then divide the sum by the number of members in the set. So as an example, find Susan's test average given scores of 63, 92, 79, and 97. So we're going to start by finding the sum of those numbers. What is 63 plus 92 plus 79 plus 97? And you can absolutely bring up your calculators and do this on the calculator. 63 plus 92 plus 79 plus 97. My sum is 331. So I'm going to take 331 and divide that by how many members of the set were there? 1, 2, 3, 4 items in the set. So I'm going to divide 331 by 4. And I get 82.75. So we're dividing by 4 and getting 82.75. Now the direction said to round to the nearest tenth if necessary. So to the nearest tenth, we look at the 5 and it tells us to round up, so we get 82.8. That's Susan's test average. Example number 2. In Arkansas, meteorologists consider January, February, March, November, and December to be the snowiest months. January has 2.3 inches, February has 1.4 inches, March has a half an inch, November has 0.3 inches, and December has an average of 8 inches of snow. What is the average in inches of snowfall in Arkansas during the snowy months? So the first thing we have to do is add up all of those numbers. So we have 2.3 plus 1.4 plus 0.5 plus 0.3 plus 0.8. Whoops, I didn't do that very well, did I? I'm going to show you a trick here. If you do second enter, usually brings up the last line. Second enter, and I can go back. My cursor was a little bit sensitive there. It gave me an extra 8. So our sum is 5.3. So we're going to take that sum, right? Those were the snowfall averages. Okay, so that's our total. And we have to take the total, 5.3, and divide it by the number of things that we were adding. 1, 2, 3, 4, 5. So on my calculator, 5.3 divided by 5, and that gives me 1.06. So my average snowfall during the snowy months in Arkansas is 1.6 inches. Next, we're going to talk about how to calculate your grade point average, something every student should be able to do. For each course, you get what we call quality points. So we've given you this table in your workbook where each grade corresponds to quality points. An A is worth 4 points, a B is worth 3 points, etc. For each course, you multiply the number of credit hours times the quality points. Then you find the sum of all of those products. Find the total number of credit hours and divide the sum by the total number of credit hours. So if we look at the second chart that's in your workbook, we're going to kind of follow this through step by step. So the first thing we need to do is figure out how many quality points each grade gets. So we said an A is worth 4 quality points, a B is worth 3 quality points, and a C is worth 2 quality points. So I looked at the grade and filled in the quality points. In step 1, it says multiply the number of credit hours times the quality points. So we're going to multiply these two numbers here. So if you look at the right-hand column, it gives us a product. 3 times 3 is 9. Next one, 3 times 5 is 15. 2 times 3 is 6. 2 times 3 is 6. And 4 times 3 is 12. It says find the sum of all of those products. So that's what we're going to do in that last column. We're going to add up all of those numbers. Again, feel free to pull out your calculator and do that on the calculator. I think that should be 48. And it also says in step 3 to find the total number of credit hours. So we're going to add the column that says credit hours. 3 plus 5 plus 3, 3, 3. I get 17 credit hours total. And to calculate the GPA, we're going to do the sum of P divided by the sum of C. So we're going to take 48 divided by 17. I am going to pull my calculator up to do that calculation. And I get 48 divided by 17 is 2.83. Okay. Normally we give GPAs to 1 or 2 decimal points. So if we keep to 2 decimal points, we're looking at the 3 that rounds down. So GPA 2.82. Got a couple of examples to do. Well, that was example 1. This is example 2. Mary is worried about losing her scholarship. She knows that she will have A's in her 3 credit hour math course and her 5 credit hour biology class. She will have a B in her 3 credit hour history class. Her grades in psychology and art history could either be a B or a C. Calculate her GPA in 3 ways. First, with B's in her 2 questionable courses. Second, with 1 B and 1 C. And third, with 2 C's. What grades will give her at least a 3.25 GPA so that she can keep her scholarship? Okay, so let's look at what we know. She's going to have an A in a 3 credit hour math course and a 5 credit hour biology course. So she's going to have an A, which is worth 4 quality points times a total of 8 hours. Okay, so these are the quality points, these are the credit hours. So her product here is 32. That we know. It also says she will have a B in her 3 credit hour history course. The B is worth 3 quality points, and we know she's going to have that in her 3 credit hour history course. So that could be another 9 points. And then we have to look at our options. So the first one is to say 3 credit hour psychology and 3 credit hour art history will be B's. So she's going to have B's in her, which is 3 quality points times those 6 hours is another 18 points. Total number of credit hours is 17. The sum of those products, 32 and 9 is 41, 59 points. So to find her GPA, we will do 59 divided by 17. And I never like doing those by myself. 59 divided by 17. Use that calculator. So it looks like 3.47. 3.47 for her GPA. Now, what if we change this and we say the first two lines are going to stay the same? She's still going to have an A and a B. 4 times 8 is 32. 3 times 3 is 9. But this time she gets one more B and a C. 3 quality points for 3 credit hours. 2 quality points for 3 credit hours. So this time she still has 17 credit hours, but this time our sum of the products, 32, 41 is only 56. That's right. So the GPA is 56 divided by 17. So let's pull up the calculator. 56 divided by 17, 3.29. Okay, so she needed to maintain a 3.25 for her GPA. So she's okay if she gets 2 Bs. She's okay if she gets a B and a C. What happens if those last 2 grades drop to Cs? So the first 2 are going to stay the same. The A and the B. 4 times 8 is 32. 3 times 3 is 9. But then what happens if she gets C's or 2 quality points in those 6 credit hours, those 2 questionable classes? She still has 17 credit hours, but now her point total drops to, let's see, 32 and 9 is 41, 53. What's 53 divided by 17? On the calculator. This time it's a 3.18 if we round off. That is not high enough to keep that scholarship. So what it shows is that she has to get at least a B and a C in her psychology and art history class. Otherwise, she is going to lose her scholarship. Next, we're going to talk about some weighted averages. In a weighted average of a set of numbers, different numbers count as a different weight or a different percentage, like when we're calculating course grades. To find a weighted average, multiply every number by the associated percent. Of course, we change the percent to decimals when we do the multiplication, and add all of the products together. So example 1. Students' grades in a certain math course at UCA are computed using the technique of weighted average. Exam scores count as 40% of a student's grade. Quizzes count 10%. Homework counts 20%. And the final exam counts 30% of the course grade. What is the student's weighted average if his average on the exams is 74, his average on the quizzes is 85, the average on the homework is 92, and he made a 78 on the final exam? So if you notice, as I was reading that, I was kind of underlining, trying to associate things together. So to calculate the weighted average, it says multiply every number by the associated percent. So if we break this down into exams, quizzes, homework, and the final, and I know that's hard to see because I wrote it in yellow, What we can do, exams count as 40% and his average was 74. So 74 is the number and we're going to multiply that by 40% or 0.40 plus his quiz average is 85 times the associated percent, 10% or 0.10 plus homework, 92% on the homework times 20% or 0.20 plus the final exam. Let me change to green here, a little bit easier to see. 78 on the final times 30% of the course grade. And I am absolutely going to do this on the calculator. And my answer here says round to the nearest percent. So what we have here, 74 times 0.4 plus 85 times 0.1 plus 92 times 0.2 plus 78 times 0.3. If I add all those up, the average or the weighted average is 79.9. If I round to the nearest percent, it's an 80%, which in my class, if I'm doing a percentage grade like this, that would be equal to a B. Okay, but this student has an 80% course average. Let's do one more example of a weighted average. Charles wants to get an A in his biology class. What will he have to earn on the final exam if he needs an average of 90% to get an A? His exam average is 89, the lab grade is 87, and his quiz average is 93. The professor counts the exams as 40%, lab grade is 25%, the quiz average is 15%, and the final exam as 20% of the course grade. So, what we know is that he wants to get an A. So his average needs to be 90%. So 90% is what he needs. His exam average. Exams are 89, and the professor counts exams as 40%. Plus, lab grade is an 87, and the professor counts that as 25% or 0.25. Plus, the quiz average is 93, and that counts as 15% or 0.15. And the final exam grade, that's what we don't know, plus X times 0.2 or 20%. So if we think about how to calculate all of this out, I'm going to do this whole calculation up to here on the calculator. So I'm going to have 90 equals some number plus 0.2x. So let's calculate that on the calculator. We had 89 times 0.4. Whoops. Plus 87 times 0.25 plus 93 times 0.15. And if we do that, we've got 71.3. So 71.3. To solve the equation, we need to subtract 71.3 from both sides. And I'm going to pull the calculator back up to do that. 90 minus 71.3 is 18.7. So we get 18.7 equals 0.2x, and to solve for x, divide by 0.2. So our final answer, what does he need on the exam? We've got to divide by 0.2, and we get 93.5. So this student needs a 93.5 to get an A in that biology class. And that concludes section 6.2. Please work on the homework and the quiz. Have a good afternoon.